Now, what about this function? Example 3. This is called the unit step function. And what is going on here? Let's see whether this function has a continuity throughout. But just by looking at it, if I were to trace this curve or the straight line, it jumped right there. So if I were to trace it, maybe I will use a highlighter. If I were to trace it, and then I jumped. I lifted my pen and I jumped. And that's why it is called a jump discontinuity. And where does it occur? At x equal to 0. That means at the origin. And let us see why u of x is not continuous as far as its limit is concerned. Okay? So why? Why is it not continuous? Take the limit of f of x as x approaches 0. What that means is I'm approaching 0 from both sides. I'm approaching 0 from both sides. Well, the limit does not exist because from the left and from the right they don't meet at a common limit point. That's why it's not continuous. Even if f of 0 is defined to be 1. Which brings us to the continuity test. This is just a good checklist to find out whether a function f is continuous at an interior point. Okay? And it's continuous if and only if it meets the following 3 conditions. The first thing we have to look at is, does f of c exist? Next, does the limit exist as x approaches c? And then finally, these two should match. They have to be equal to each other. The limit of f of x as x approaches c has to be equal to f of c, the function value right there. Well, let's just graph it and see what this meant. Just for emphasis, I will just put a covered hole there just to make sure that we can see clearly. So if this is c, what is the y value right there? The y value is f of c. Let's look at the checklist. It says, what is being asked for here? Does f of c exist? Well, it's right there. Okay? There's the point c, f of c. And then what is the limit of f of x? As x approaches c, it is in fact f of c. So this already covered the third condition. So first of all, it exists, the limit exists, and they are equal. Let's look at this greatest integer function. What is the greatest integer? Well, let's just try some function values and to test what it means. Okay, when I have y is equal to the greatest integer of x, this means that if I take the greatest integer of 1.5, it is the largest integer that's less than or equal to 1.5, which means it's 1. What is the greatest integer of 0.5? The largest integer that's less than or equal to 0.5 is 0. What is the greatest integer of 3.11? It's 3. And all of that can be seen here. If my x is 0.5, see my y value is 0. If my x is 1.5, there is the function value. Okay? If x is 3.11, then there is the function value. It's equal to 3. So the greatest integer function is continuous at every non-integer point. And it says here it is right continuous, but not left continuous at every integer point. Let's see why. Why is this true? What does this statement mean? Why? Why? It says it's right continuous, but not left continuous. Well, let's see. Let's examine the limit of f of x. Let's just choose, say, 3. I mean, we could use 1 to any of the integers, -1, 0, and so on and so forth. But I'll just, pick randomly 3. What is the limit of f of x as x approaches 3 from the right? Okay, I am approaching 3 from the right, and what is the limit? It's equal to 3. Question: what is f of 3? Well, the greatest integer of 3 is 3, which makes this right continuous. Therefore, f is right continuous at x equal to 3. Now, next question. Let's use a different color just to distinguish the two. What is the limit of f of x as x approaches 3 from the left? I am approaching 3 from the left, and what is it? It's 2. But question, what is f of 3? We said earlier that f of 3 is 3, so it's not equal to each other. Okay, that's why f is not left continuous. Here are just examples of different kinds of functions, and the only function that's continuous here is a. Okay, but the rest, b, c, d, e, and f, all of them are not continuous. Okay, so this is not continuous, not continuous, not continuous at x equal to 0, not continuous at x equal to 0, not continuous at x equal to 0. Okay, let's examine why. For letter A, the limit of f as x approaches 0 is 1, and in fact it is f of 0. The limit exists and it's equal to the function value. Now let's look at letter B. There we go. Okay, what is the limit of f as x approaches 0? It's 1. Question, what is f of 0? F of 0 does not exist. Okay, which already, if we look at our checklist, remember our checklist says this f of c here is 0. Does f of 0 exist? Well, it does not. So already it did not meet condition 1. Okay, and let's look at letter C. Here, it's very similar to letter B. The limit is the same. The limit of f as x approaches 0 is what? It's 1. However, what is f of 0? What is f of 0? It does exist, so condition 2 is met, but they are not equal. Okay? So they do not match. They're not equal to each other. That's why the limit, or rather, f of x is not continuous at 0. And what about in letter D? Oh, that's just the jump discontinuity that we were talking about in the previous slide. So here the limit of f as x approaches 0 coming from both sides. Okay? That means the limit does not exist. Although we have a function value there, but because the limit does not exist, okay, f of 0 is 1. Okay, so condition 1 is met, condition 2 is not, so we stop. We say it's not continuous. How about at f of x equal to 1 over x squared? Okay, first, what is f of 0? It does not exist. What is the limit of f as x approaches 0? It's not a real number. It approaches in positive infinity, so again, it does not exist. And here it's been an example that I have been showing to you. And so what is the limit of y or f as x approaches 0? It does not exist. And of course, f of 0 also does not exist. Now, there's one thing that we also have to notice in all these examples that are not continuous from B to F. B and C are called removable discontinuity. Why is it removable? Their limit exists, The only thing is that either f of 0 does not exist or f of 0 does not match the limit value. Okay? So when we have this situation, then we say that the limit, or rather the discontinuity, is removable.